Thank you for coming to my talk today. So today's topic is very simple. It's an introduction to what a server-driven UI is. We'll be talking a bit of different libraries that you could use, different architectures, and what to go about in, building one in-house or using something that already exists. Okay. So with that, let's get started. Oops. Yeah. I'm Adit. I'm an Android GD, currently working as a self-employed. I travel the world. I play around with different projects and different clients across the globe. You can find me on my website, or you can reach out to me through my calendar link, which will be available at the end of the slide. Sorry. With that, let's start with what should we expect from what a server-driven UI is. The most common thing that many people are afraid to start off is the fact that the server-driven UI is controllable, not by the front end, but now from a backend component. So a backend engineer who's now only sending you data is also sending you some more component or some more meta that the front end needs to react to. So how do we control these core UI components? The biggest use case could be, say, something like a shopping app. How many of you use Walmart here, right? Everyone has some kind of a use case across shopping. It could be even a dating app. What if you want to control some of the UI components on the homepage? Or there's a search page where you want to control certain elements of the search page. So I want to kind of control these components in such a way that server JSON or kind of global config can just tell me in an API that this is what needs to be drawn, and the front end just reacts to it. Okay, so that's what we're trying to achieve today. It plays very well into the A/B testing. Now, what is A/B testing? A/B testing is simple. I want to play with the pink color on one side of the users. I have 100 users that are going to be on the blue, some 100 users on the green. What if I want to play experiments and see which one works? Or it could be a different icon, or it could be a different layout altogether. What if I want to control all of that without actually going and deploying it to Play Store, right? This really works well with feature flags. If you want certain things to be turned on and turned off on the fly, you can actually now start doing it through server-driven UI. Now, since I'm talking on the UI layer, I'm not going to be touching a lot on the data layer, but it's still going to be very close to how to build it all from the scratch. And the best thing that we could do today is to build it once and take the benefits over and over again, right? You can build the components. The keyword that I'm saying components is basically a library of UI elements that you could just place together or as an individual component, and then build it as a screen, and then the screen gets rendered for whatever use case you have on your app, right? Now, what is the goal for today? The goal is very simple. The UI should be a breeze to change. I have personally worked on multiple apps where there are so many UI changes. The product manager comes or project manager comes and says, hey, Adit, I want to change this. This doesn't look good. You have like 2 days, 15 hours to complete this particular task. Let's get this small tweak there. What if I say to that manager, hey, I don't have to do this anymore. I can just tweak it from a server config. We can run an A/B test on a few users, write a instrumentation test whether it's working or not, and test it on real life production app, right? So I want that breeze for the developers to kind of come out, and that's what the goal is. The code should be very dynamic in the sense that when we start building these components, they should be the root use of everything that we do on a server-driven UI. And when I say server-driven UI, it doesn't mean that all the components are, all the screens in your app are supposed to be server-driven. It could be just one screen that is now configurable, right? Building new UI should be as simple as, hey, I want component number B, I want component number C3, and then combine them together. Voila, I have a new card that I wanted to publish. And now that's the foreground of what a particular screen should be. So it should be really fast, right? Now, the biggest thing in development lifecycle is to learn, adopt, and test quickly. All of you, even if you're not a native developer, you must have gone through the lifecycle of going through QAs and getting your UI tested, and then managing the states of the data. How do we? What if server sends a particular data and the UI doesn't react properly? Maybe it's not carouseling on the left or the right. Whatever that is, what if we can test it faster and deploy faster? And the biggest, like the current problem that we have today in today's Android development is, let's take a simple example. We have a server or an API or a backend API in this case. Now, this is talking to the client, right? Now, this client is now saying, hey, I want this screen's data to come to me, and then I render the UI. Now, there could be another service or an API endpoint number 2 that we are talking on another screen, and this client remains the same. When I say client, it could be an Android app, it could be an iOS app, whatever that the use case is. We can keep adding these things, and as you can notice, if I'm working on a multi apps across, say, an enterprise app, or if I'm working on a project where it's not just one app, but there's multiple apps that are going to be using the same services, we'll have we'll have more complexities getting added to us. And since I'm speaking on server-driven UI, I'm talking more specifically on building these screens all over again for different clients. All the red boxes out there that you see on the screen are now clients that you have to manage on your own. And you can have a common layer where you're building the components once, but then uh, if the config changes, then you have to re-adopt all of those changes and then push a new Play Store update. Now, this complexity keeps increasing. Oh, sorry. This complexity keeps increasing and so forth. But what are the downsides of doing such a thing? So it's very heavy on the client side. Now, why I say heavy on the client side is because now you have to go through the iterations of running through the project all over again, figuring out what the screens are. If there's an existing code that you already have on the UI, you now have to or rather edit it to kind of balance to say a V2 version of the design. The designers are pounding on you and saying, hey, this is not pixel perfect, or this is not how we want it, but we wanted this in a certain way. The server, now the data is not ready, the server may be still building an API, but what if we can reduce that constraint down? So that's one downside. Maintaining more than one client now becomes a challenge because now you have to do the same thing over and over again on different clients, right? And it kind of results into duplicate code. The delivery gets very hard, especially when it is on scale. I've worked on an app which is serving about 5 different countries from a single code base, and every country has a different subsets of the features that we have. So it could be like we have a homepage where there are 5 things for the primary country that we are launching at, but there's another country where there's only 2 features, and I don't want to control the UI in a certain way, right? I want this to be very dynamic in the nature, and I can't do this if the clients are all the entire logic is written on the client side. When I say client side, again, it's the Android app or iPhone app, right? Now, building UI components from scratch becomes a tedious challenge. Now, if you have new engineers on your team who are juniors or just starting off on your project, they have to learn the design system or whatever framework that you use for your UI and then take it from there and then start building new screens. And that becomes a learning challenge for them as well. So what if you can, improve on some of these points? So what are we going to change? First thing we're going to do is write code that can render state. Now, this concept has been there since a long time, right? Now, when I say state, it is something that a backend is telling you that this is what I want to represent. And the front end, in a very simple and a very layman language, I do make a joke about this. Android apps are more like a read-only apps because they're reacting to something that the backend is trying to say, right? So we are trying to render a UI based on what the server is trying to say. We take those events that the user interacts with on the UI and then convert a state and morph it into another state. Now, when these state changes occur, what is the transition happening? So we're going to be like working on these 2 or 3 points. Now, what the idea is that UI is a function of state. It's been a wholesome experience where even if you don't do server-driven UI, you are talking to an API or a data source like a database or some kind of a preferences or whatever data inputs that you have. You're taking that data and then dumping it on the UI and saying, this is what my list would look like, this is what my buttons should react to, and so forth. So what I'm trying to say here is that UI is a function of state. I'm just using Kotlin in this case. Now, we have an idea that we have to build UI, but it's a function. It's something someone has to give me an input of state, and then I'll render it, right? So what's the idea that we're trying to achieve? It should be easy to understand. Any engineer on the team, whether it's back end or front end, should be able to correspond together, right? It should not be only a front end code which only the engineers on the mobile team know, but then the back end are you're going to send it in this way, but there's a friction between the 2 teams together. So it should be easy to understand. The designers should be plug and play, right? They should be flexible with whatever we're trying to achieve, and they should be able to put their inputs in. We should be able to launch to Play Store without actually, like going to Play Store. So what I mean is we'll have version 1.3 and something like that, and we can just change the homepage on the fly, and that's very critical here. Why do we do this? Is because so that we don't repeat ourselves. We minimize the approach angle towards, delivering some new screens without actually building it on the front end. It should be very easy to maintain, right? Now, let's take a breakdown of what we're trying to achieve, right? We have a state. We're representing as a box. What we're going to do with the state is it could be anyone who's providing it. It could be backend, it could be a local database, it could be anything that is a representation of your data. We take that state and start putting into a rendering engine. When I say rendering engine, it is basically, it could be a recycler view, it could be a compose function, whatever it is, you're passing some state into a function. That function is now responsible to draw those components for you, and those components are then part of your library. Now, the rendering engine is responsible to maintain a plethora of these components and start drawing it, okay? If I start with the rendering engine, that's where the code entry point is. If you can see on the screen on the left side, we have a nice little simple, very simple design at this point. We have a card which reads my name out. It shows my title. There's another card which is purple in color. There's some icons and text. There's some buttons and checkboxes that I want to control. I don't want to build it. If I have to build this XML or a compose-driven Android app, very straightforward, nothing complex. But what if I want to change the ordering, or what if I want the purple, the card view to change to a blue color card view, and the text to be hey Adit instead of hey Adit, it becomes something else. So if you have to do all of these, you can do it with a simple server-driven or server API, consume the data, and then just pass it to the UI layout or compose function, and then manage from there. But what if I tell you that this can also be rendered through a render engine, right? And these components, all of these square boxes that I've drawn in gray, are now individual components. You can think of each of these as individual components or a group of these components together. A very similar concept of what view and view groups are, right? Now, what does the UI equation look like? I mentioned something about UI is equal to a function of state. What if I say state is equal to JSON, which is pretty straightforward? It could be anything else. It could be protocol buffers, anything that delivers data to you. Now, when I say a state is nothing but what a backend is. That if I take a banking example, banking APIs would be like, hey, you have $10,000 in your account, and there's this UI which shows my account balance. That state is representing this data for me. So I'm converting this API and taking the JSON and adding some meta on top. Now, JSON could also be a backend, very simple equation. So in other words, what I'm trying to say is UI can now be driven by a backend function, right? So a backend says, this is my state, please render based on that state, right? Now, there are some frameworks out there that are pretty straightforward. There's Epoxy, Litho, Groupie, Compose, obviously, which is very, very powerful now. What we're going to be doing is we're going to be focusing on Epoxy and Compose. There are a lot of engineers out there who are still not adopting Compose as much as Google really wants to, but then I'll still work through the Epoxy solution, which is, even though it's a bit outdated, it's not maintained much, but then still very, very powerful and very powerful on the recycler view, which is the core of Epoxy. We'll also be taking a look at how to do this on Compose, right? So to quickly go through Epoxy, let's say we have this response, the blue color box on the left side. We take the data from that and then convert it into a state object. Now, state can then go to a library of UI components where the rendering engine says, I want component A, I want component C, I want component D, but with a mutation. It takes those things and then builds those containers. Now, when I say containers, it could be, because Epoxy is based out of recycler view, it's all put together. It is rendering each of those rows. The concept of Epoxy is that you have rows that can be represented as one state per row. The state could be a list of these rows, or it could be a list of, say, some carousel events on a horizontal card, whatever the design aspect is. Now, when I say these concepts, we are talking about components again. Now, components are something that you build as a design system library. I keep mentioning this keywords called design system. Design system is nothing but a framework or a library sitting inside your internal tools or an external tool where you get your components from that. You can have text views, buttons, and so forth. And there's a network layer on top, which then converts a JSON and then renders the UI for you. Okay. A very simple example of how Epoxy works is that red box outside is the container where everything's drawn. It could be a recycler view. Then comes your internal yellow color box, which is now responsible for how the layout is going to be structured. And all of these green boxes that you see is just elements that you want to be placed in individual rows. It could be a small little row, which is, say, 100 by 100 pixels of height. There could be another one which is 200 pixels. It's all dependent on how the components or a group of those components come together to form another element on your screen, right? So if I take this example of a checkbox, just to give you a little example, how would I represent this in a JSON format? I would probably do something like this. I'll have a state which says it's enabled or not, whether it's selected or checked. I would have a text representing what the checkbox is, and then I'll have a view type. Now, what I'm trying to focus here is that view type is a discriminator in the world of JSON, where we have a specific type that's telling us, hey, this is a checkbox type. And we have a direct one-to-one mapping that the backend sends. It could be a checkbox, text, a button, or anything else. And the front end would react based on whether they have that type or not. You can also play very well into the versioning of these components. If you don't have a version, you can just don't draw it, or you can send an analytical event back home, and some PM will get an alert saying, hey, server sent a JSON component that was not present on the app, and the versioning is out of sync. So let's publish a new version of it. Now, what we're trying to do here is, let's say we want to build this screen from scratch, right? And instead of doing it through XML or Compose or whatever else you guys deploy, let's see a JSON version of it. So if I have to build this first card, what do? I actually put an ID. Now in Epoxy, there is a very simple concept of every element that you draw on your screen has to be unique. So depending on this ID, they then do the diffutal for you. The recycler view concepts are very similar. The view order pattern, everything is there. Then it looks at something called as children. Now this is the structure that I'm just showing you as a prototype. It's not something that is like a standard practice. What we're trying to do here is we have a discriminator which says it's a view group. And there's a specific type that I've now defined as a subtype, which is called a card. A card is nothing but it draws a card view and then you can throw in anything inside. It could have a linear layout, it could have a constraint layout, whatever you need. Now, these are all XML based things, but we'll also come to the Compose side very soon. The key over here is that when I send this to parameters, it's drawing a card over there for me. Now, by default, I don't have to say any padding and so forth, because when I work with my designers, the patterns of design are very crucial. So all the paddings that are there required is already handled by the component rendering engine. In this case, the epoxy. So when I say I want a card view, I'm drawing a, sorry if it is not visible here, but then we do have the card drawn on the right side, okay? Now, the first thing I'm going to be doing inside the children block is going to be passing another discriminator, which is called view type. I pass a simple meta called image URL. The rest of it is handled by the, the rendering engine. So the rendering engine is now going to take the image URL provided and then draw an image view out of it. Okay. Similarly, I want to draw another thing called a view group, which is of linear layout type. Now I take this and I say I want two text views, and I say it's a vertical linear layout. So I'm just trying to add a little more, flexibility to how the server could send some data, and then the front end rendering engine could then map it to a component. Now, all of these view group types are individual components that I'm now combining together in an array of things called children. Now, when I draw this, it's going to be drawn as a single component, and then you get this whole thing together. Okay, the code would look very straightforward, but then we'll come to the network layer very soon. Now, if I have to do the second card, just as an example, again, the same prototype, I have a card, which is the outer layer. If you realize there are curly braces on the JSON, the top and the end. And inside that, we have children, which is, again, there's a new type called icon now. We pass some colors and some meta. I'm just using enums here so that 11 represents, say, the chat icon that you see on the highlighted area. Now, when I take all of this together, I have a text type, which is another component. I piece it all together. It becomes a component that I can now render it on the screen. I take all of these components, the checkbox, the cards, all of these things, and then push it into a JSON server-driven UI, and then that becomes my API. This API can now be controlled however you want from the backend, right? Now, this concept can now go further, and now we're going to look at how Epoxy works. It's based out of Recycler View. We have simple things. The data forms the state of the UI and then goes into the Epoxy model, which is the central layer. Now, this Epoxy model is now going to be the view that represents the Recycler View. So all of this that you see here is how we have a unidirectional flow. What that means is the view is now responsible to say, hey, there's something changed. I want the state to update. It's not that the state can tell the view that, hey, I have to update. State is immutable type. Now, when someone triggers, let's say a click listener on a text view, I want to click on a button, or the text view is, or a checkbox is selected. The view is calling a callback, and then the state is updated at a different part of the code. And then that state can now mutate and say, hey, there's a new epoxy model. The differentiator is, if you remember, there was an ID which did not change, but the value is selected as changed. If I take the checkbox example, right? Now, in a very simple common sense, it's not to be confused with architecture components. Epoxy model can be kind of related to a view model. Now, the view model as a whole is just, in other words, something like this. I have an item to represent on the screen, a single row of my recycler view. I convert it into an epoxy model. I then connect it to a layout resource, and then that gets rendered through the epoxy recycler view. Okay. Now, coming to the code, it's all fun and great to see JSON, but let's look at Android code as well. We have a simple interface that is passable so that I can then pass it around different components. It's a simple interface that just gives me an ID so that every component can behave to the same, the ID that the epoxy requires per component. Now, if I have to define a component data, I have another interface that extends the base. What I'm doing here is I'm giving the width, height, there's some padding and some gravity and some extra payload. If you want to kind of control, say, if you want to pass some lambdas in or some functions, you can actually pass it in the extra payload as a pass level. Why we do this is so that if I take this JSON, how does this all convert? I have a thing called view type is equal to text, a discriminator called text view component, and I'm passing the value called text. Now, these are all polymorphic data, right? These are not JSONs that you will have constantly similar to every other row. So these are all different JSON rows that we're having. So I take that and I create a data class, which then extends component data. The two things that I want you to focus on are the view type, which is overridden, obviously, from the common interface. And then there is this variable called text, which is already pre-initialized. If the server doesn't want to send something and it wants to hide it, we can have some control factors as well coming out of the rendering engine. Now, what this does is we also write, we have written the data layer, which is now representation of data. We now write the epoxy model, which is the middle layer. Now, what we're doing here is we're writing an abstract class. Remember, epoxy works on annotation processor. So what it does is it generates code for you. What we're doing here is we are extending epoxy model with holder. We pass in a view holder pattern, very similar to what you would do with your recycler view. Instead of declaring everything as single, like recycler view with homogeneous views, we are now determining it through heterogeneous. What we're doing here is we are taking those view holder patterns similar to recycler view. We're giving the text view, which is the component, which is the underlying component. You can have your own, I don't know, like something like custom internal text view, which has all the font and the emoji support and whatnot. You can have that. We bind it through view binding, and then we say there's a concept called epoxy attribute, which then passes the state value in to the epoxy model. So depending on the unidirectional flow, if the state says the text is hey Adit, it's going to be passed in through this variable, which is just now highlighted. And then the bind logic, which is very similar to recycler view, is going to bind it and then set the text onto the data. Okay. Now, there's another thing, which is the something like an adopter of recycler view, which is the controller in this case. What we are doing is we're using typed epoxy controller because I don't know what type I'm going to get. So I'm going to be very biased on, depending on the type, I'm going to decide which the when clause I'm going to be using. If you're familiar with Kotlin, when clause is being used here. What I'm doing here is I'm taking a data object, which is a list of base component data. This is my JSON data morphed into, or rather, sorry, deserialized into a data class. And then data class is then passed on to a function called generate model, which then builds the models for me and then renders it for me. So how does this all work together? If I start putting this together, I have a component click handler just to show you that we could add click handlers, we could do long clicks and whatnot. I also have an uncaught view data so that I can at least report if there is a versioning issue. Like if I did not have a component such as say button number 3, I don't know what button number 3 stands for. That's the discriminator in the JSON. I can at least report it back and so forth. So what we're doing here is we're taking and iterating over each and every row of my JSON array or the JSON or the list that we have just provided in. We then call a function called generate model. Nothing crazy here. We take each of those components and then say, please generate a click handler and the uncaught. If it is not drawn, please add it. The last line, add to, is to take that data and then draw it on the epoxy recycler view. So that add to can also be conditional in epoxy. If you want to add it only if a certain flag is on, you can do that. But the add to by default is adding it to the epoxy recycler view. As soon as this is processed, your recycler view will draw whatever content is on the screen. The good thing about epoxy is it is very diff-util friendly. That means even if the server sends a new JSON, which is a new array list with just one meta change for one of the elements, it'll take that data and then pass it further down. And only that row would be updated. Nothing else will flicker or nothing else will update. Now, what we're doing here in the generate model is pretty straightforward. It's just an extension function, which is taking the data or a state, converting into an epoxy model so that the epoxy recycler view or the controller in this case can then react to it. It's a very simple when clause. There could be multiple maps. I'm just showing you a very one-to-one mapping of a text to its text component data. What we're doing here is, if the type is text component data, because of the discriminator, we are telling exactly what that view type is. We are then, if you notice, there is a thing called text component underscore. This is the auto-generated class from the epoxy. This is your epoxy model, converting it into a view layout, and then passing in the meta that we have. So any epoxy attribute that you have, such as the text component data, we are passing data in, it takes the text and then draws it. Nothing fancy here. And if I have a click handler, it can also do that for you. Okay. Now, what I'm doing with all of this together is I like to build custom views. What I mean by that is I don't want to write epoxy recycler throughout the source code. If I have to upgrade from epoxy to some other library, I don't want to go over that. So just as a precaution, what I've done is I built a custom frame layout, which is basically just piecing it all together. I have a component click handler. All the logic is sitting in a custom view. The epoxy recycler is right here. The controller is initialized. At the same time, I have a layout manager, very similar to your recycler view. You have to provide a linear layout manager, a grid layout manager, whatever else you have in the pipeline. We then take a binding of that particular component and then inflate it. So I have this layout, which is basically a screen list view. All it does is it just inflates a recycler view, which is an epoxy recycler view, as a full width and a full height in a particular screen. And then voila, that screen now becomes any activity that adopts that screen is now server-driven UI. Okay. With that, I also initialize the recycler view, connect the layout manager, connect the adapter, or in this case, controller, nothing fancy here. Set up the click handler so that I can pass in the lambdas or the reference points for it internally. Now coming to the magic of all of this put together, now this is the JSON. This is where the component runtime, or in JSON library, I've just taken JSON here. I'll also show you Moshi example later on. But I have this JSON library, which has something called the runtime polymorphic data adapter. What we are doing is we are saying the discriminator is that type view type. If it is available, this is a discriminate or a polymorphic data. Depending on what it is, you start building those registered subtypes. So if it is a text, the text component will be handled for using the text component. If I have a checkbox, a card view, whatever it is, we can then go further from there. Very simple. Wherever you're initializing a JSON, you're taking the JSON.set pretty printing. We're taking those runtime adapters and adding it to the JSON instance, and then that's about it. The sail class type that I have done as a fancy thing is just so that I can control all these parameters together. Cool. Now with that, I'm also going to jump into Compose because that's where the fun and exciting things are. Epoxy is a bit out of date. Now, keeping in mind that UI as a function is a function of backend or a JSON, it's also a Kotlin function to represent a screen, or it's a declarative UI, right? Very similar. Sorry, I have lack of illustrations here. Very similar concept. We have a compose that is going to be a container. We're going to be doing something called as hoisting. Hoisting is where a particular compose component, a single row, does not care about its state. It's a stateless compose function. The container which is drawing it is now managing the state for it and then giving the control based on that. So what that means is, let's say I want to build this food delivery app. Now, this is an example of a food delivery app from back home in India. It's called Swiggy. It's just a replica of what's happening there. We have these banners and carousels on the top. We have some categories that are color-coded icons. And then there are these popular restaurants that are listed as a vertical list. If I have to build this in Compose, I'm going to break this down into something like this. So we have a banner on the extreme. On the second image, we have the first left corner, which is the 30% off a food dish item. Then there is the title view, which is popular this week. It's just a heading with some see all function, which is a CTA button to take you to more of these things. Then there's the icons, and then there's so many more things here. What if I have to build this from scratch? So again, for people who are not comfortable with Compose, let me just break it down how it works. I have a composable function, nothing fancy, it's Kotlin. So we have a container. Again, this is just putting a small width and height. It's a very crude way of saying the better layouts in Compose, but I'm just using a very crude way of showing you what we can do. So what I'm doing is I'm drawing a rectangle, clipping it with some rectangle shape, and then drawing the image. These are all custom functions where I've given a particular resource. It could be an image URL, it could be a drawable resource, and then passing it in, and this is what it gets drawn. But what if I want to draw like a small little scrim at the bottom, which shows a text for me? For doing that, I would then take the same function and take a text view, or in Compose, it's a text function, pass in the little text that I want to draw, and then just put in font size and whatnot, and then voila, this is how Compose would work. Now, all of this is great. This is just an intro to Compose for people who have never used it before. But the fun part is, how do we do the hoisting? Now, when we pass the JSON that the network passes us, we need to convert it in each element into their data transferable objects, or DTOs. Very similar concept, right? What we do here is we have a composable element. It's just a simple interface that is now going to return something called as a compose function. So every element that is going to be mapped back to its component in the network layer is going to be represented by this thing called composable element. What we're doing here is we are passing in a hoist. Hoist is nothing but someone else will tell you what the state is. You just react to it. It's a unidirectional flow that I'm trying to achieve here. And then there is another method which is called get hoist, which then gives me the map. Depending on what the key is, it's going to tell me what the state is. Okay. Now, if I take the same example, what would I do here? I would take that function and convert it into a class just for the sake of argument. I'm going to take something called as an element DTO. It's just a data class, which is representing the state for this particular element or this banner thing. Now, what I'm doing here is I'm taking that and extending the class to composable element. There are two overridden functions. One of them is compose function, which is going to invoke the compose function when the draw occurs. That's all we are doing. And there's another thing called get hoist. If you notice in the get hoist, all I'm doing is just passing a mutable state of the key and the value, which the value here is just what is the default value for this text view. Cute puppy is the text I'm getting from the server side, so I want to draw that. So, but the function compose is responsible now for the @ composable, which is now going to get rendered. What gets drawn inside, you could call another function. This is just for brevity. I've written everything here, but you could also have another private function or some protected function that can just be triggered from here. Okay, the same code what we had, but instead of you passing the hard-coded elements, what I'm doing is I'm taking the hoist or that state object and then saying I want this field name. So there could be something called as the icon URL is equal to something, or the puppy's image URL is this, and there's a text. I know there are two things that I need to draw. The first one is the hoist.image URL. The second one is hoist.getText, and that's what I'm doing in these two cases. In text case, all I'm doing is hoist.get field name. The field name is the text view. Instead of you hard coding these things, even the backend could send you a different key, which I have no idea of when I'm building this code. So I'm giving that flexibility right here. Okay. We could have many things. We could have banner, text, promos, headlines, whatever. Your imagination is going to be really useful here, right? Now, what we're going to do is we're going to take those DTOs. What I've done is I've created a data class. Now, I'm using Moshi in this case just to spice it up. I'm saying I'm going to generate adapter for this. All I'm doing is I'm taking a JSON array and saying there are these children elements that I'm going to be drawing on the screen. It could be a vertical scroll. So if you realize from the previous the design screen that we had a vertical list with some horizontal components. So I'm taking those vertical lists and having children for that. Every children would have something like this. Now it's going to have a label, which is going to be the key to your hoist. It's going to have a view type, which is going to be useful for the network layer to kind of discriminate and say this is what it is. And then there's a default value, which if you don't want to take what the server is saying, you can also pass in a default value from the front end use case, like a data store or something, or a database. Now, what I do here is I also built a very simple thing called empty element. What if a server sends a component which I don't recognize? I still want to draw an empty space without actually consuming anything so that at least something gets mapped. What I do with the compose is it's just a dot. It's a white space and nothing gets drawn. I take this empty element and keep this as a backup in case when the when clause is in the else condition, this could be taken care of. If I have to do other elements and then piece it all together, I have a class that is called screen, which takes in screen data. So for every screen that you're going to be building, what I do is I take the screen class and then call it into the activity that I need and then write it into a compose function. What this does is it takes every element of that screen and then starts calling the compose function. If you realize this is having a compose function, which then just iterates through the elements I want. I could use a lazy column, I could use a column, whatever is your preference here. If you don't want scroll, you would use column. If you want scroll, you would use lazy column or lazy grid or whatever else the design architecture of your screen is. What I'm doing here is taking and iterating over all of these things, getting the composable element out of it, and then I'm using the compose functions composable to trigger that thing for me. This is where the trigger occurs, right? Now, for every element, I'm also calling the compose function, which then renders the UI for me in this particular column. So instead of you drawing it, like writing a compose function and calling 5 different functions, I'm saying all the components that are supposed to come in whatever order it is from the server, it's going to be triggered by this particular architecture. I don't have to rewrite the screen as a class because now this could be called in something like this. A very simple thing, I have main activity extending component activity. This is a slightly old piece of code, but then now we can just extend app compact and compose. All I'm doing is view model providers. Again, I'm using architecture components. Again, not to confuse with epoxy. Sorry for that confusion. All I'm doing is, I'm calling the view model and I'm saying I want to draw this content now. What I'm doing here is I'm taking a data class string holder. I am creating a mutable type of string holder, which says that anything that comes out of the server, I'm going to take it and convert it into an ambient thing. Now, the ambient API in JetPack Compose is very, very important because you can pass a data indirectly into a child component without actually, it's a very declarative framework, right? So you're taking that ambient API, you can kind of compare it to, if I'm not wrong, the context in React, there's something called environmental object in Swift UI and so forth. What this does is it's taking that element of things and any children that accesses it can now take the provider of or access anything that the provider is providing. When I say provider, I'll come to that now. So if you look at this my screen content, this is just a simple compose function. This is the entry point to the screen. What I'm doing here is I'm taking the view model, taking the server call. It's already invoked. It could be it could be coroutine, so it could be Rx, whatever is your poison. We're taking that and converting into a string holder. Just a simple example so that I can show you how the state will be rendered. I take Moshi to start building this. Again, just for brevity, I put it in one function. You would never do this in your life. Please don't do this kind of code. It's really bad to have Moshi instance initialized every time. But what I'm doing here is I'm taking the Moshi adapter and saying, hey, I have this magic show right now. There's a polymorphic data. Please give me those elements for me, depending on what the type is. The view type is the discriminator. Same JSON that we were using with Epoxy is now also available to you in Compose. Now, remember that ambient API. Now, the ambient is very important. We are indirectly saying there is a state that's provided by the API. For every element, there's some kind of the key that I want to ask, and if there's any meta around it. So what we are doing is, if you write providers and then take those elements and then take those states out of each of those elements. Now, every child that you write will get those elements depending on the position and depending on the key. The child can say, I want this key, and the state of that particular element in that position will now be available. All we're doing here is we're taking the holder from the screen JSON.current. If you realize, screen JSON is the ambient data that we are providing in. The .current is just accessing the meta. We then pass it to from JSON and then convert it into the .compose function. This is where all the compose magic comes together. Now, putting it all together, this is a screen component. We can call this anywhere we want. So I would do something like this in my main activity, or something called as a server-driven UI activity. I would set my custom theme or material theme or whatever you would like to use in your Compose and trigger this function. Now, this function is responsible to call the state where the hoisting is occurring, and every child is going to get the state and then get a unidirectional flow. If the server changes, the view model can be observable, then that can then convert the data back to that function and then pass it further, right? Oops, sorry. Yeah, and there's another thing that I can do here is I can also write this app as a compose function where I'm doing the material theme, the scaffolding, and whatnot. All I'm trying to show here is, like, if you want to bring some states, like if you want to show loading, the three basic states of a screen. You want to show loading if when the server is being fetched. When the data is ready, you have this result.success, and then you show the actual content, or it could be a failure case. So if I just take the success case in this case, the show screen is going to be responsible for, say, something like a vertical scroll bar. It's another compose function that takes every child that the server has sent and take those elements and draw it inside a column or a lazy column, whatever the design is asking for. If it is an item, so this is where the discrimination from the network layer is now getting converted to its individual DTO. If I take the show horizontal elements as an example, quickly just going over this, I can be looking at the key. I am taking every data that is available in that key and then passing it down. I can have another subtypes of those horizontal types. I can have versions here. I want the version 2 of the banner. I can have category and whatnot. So these are all the vertical elements. There could be another function called show horizontal elements, the carousels and so forth. You can build multitude of these components. This could be part of your design system. You can have a network layer can then convert it from there. If I take it all back again, the screen is just getting some elements in. The state is being passed in. We are talking to the compose by saying, hey, every screen component that we're going to be rendering will have a function called compose, which will then be passed as a hoist. We'll pass a hoist key. That hoist key will then be responsible to then give the data to that compose function. Now, to put it all together, the app module, again, sorry, the app function that I was showing you before, it's very simple. It's just a scaffolding. I wanted to draw some kind of a toolbar. If there is a loading, there's a custom function called show loading. When the data is ready, the compose is going to draw whatever components you want. And the error message is very straightforward. Now, putting it all together, when you go back to the main activity, this is how your code would look like. Your set content would have the theme already preset. App is going to draw it. The view model is going to provide whatever the API call is going to react to that data, and then you can draw it further. With that, there are some references that you can go over. The bolded and the highlighted one is the slides for today's talk. There are many more things that you can go and look. There are lots of good solutions out there. If you're just getting started on server-driven UI, there are loads of codes that you can go and look at. There's also Beagle and Epoxy in case you want to try it your hand at. It's still maintained to some certain level. Has solved a lot of problems over the years. Airbnb used to use it quite a lot. If in case you want to go check these out, you can do this through this link. With that, I also have something funky that I've done with Compose. I've built my own design system library so that I made it open source. If you're curious, you're trying to build something of your own with Compose, you can take a look at Andromeda and see how so using those components that I've been blabbering about, the text components, the chat, say an icon component, all of those are now available here. All you need to do is add a network layer, and that's about it. And your activity can then just pick it up from there, right? With that, thank you, folks. If you have any questions, I'll be happy to answer. If in case you want to reach out to me offline, there's also the calendar link at the bottom. You can reach out to me. I have a public calendar, so you can talk to me if in case you have some more questions later on. Yeah. With that, thank you so much. If you have any questions, happy to answer. Okay, so if I got a question, so you're talking about what would happen if there's an offline condition, right? Like where the app is not connected to server. So it depends. See, like I mentioned in the earlier the start of the talk, it's all about your data structure, right? So if I talk about the UI layer only, this is how you would do it, or there could be other ways. This is just my opinionated guide. When it comes to the data, you could have a data source that could be responsible to pass the state anyways. It could be a repository pattern where you're talking to either a remote API or it could be a local data store. But ultimately, you're just getting that list of components that you can then draw and then render on the screen. It's up to you how you structure your data. If it is an offline first app, you would have the source of truth coming from the local DB, and if there's a server, like a sync issue, then the server is going to tell the local DB, and then the update comes. And the benefit of all this is only the element that is, let's say, if I take the example of the checkbox example and the card example, the local data says there's 5 cards that are there. Tomorrow or in a couple of seconds, the server API says the 6th card. Click an addition, so that data can then just be dumped from the local DB as an observable. You can read it up, then pass it to the next, the rendering engine. In this case, it could be Compose, Epoxy, whatever else you would use. Yeah. Cool. Any other questions? Yeah, sure, please.
Basically, and the idea is that you have to show the server be able to tell I guess I want to print this back now. Okay, now I'm getting the security type basically I don't print that. So it's still required an update on the client side, right?
Yes. So it's like this. So you could have a version 1 with say 25 elements and you've just gone live. But there's a 26 thing that just came up and you have to do a small Play Store update. But think of it this way. If I have to build this on XML or Compose, you would have to launch the point 1, the point 2s, and the major versions and keep going to Play Store every 2 weeks, 3 weeks, whatever the release cycle is. But for that one screen, if I can pre-plan it, if you can pre-plan it with your manager or whatever the product life cycle, you can have those 26, 27, 28 kind of batched and say, oh, we can have a default view. If you realize I showed an empty container view, right? You can have something like that, right? You can have a text view. Sorry, this view, you can take the element from it, convert it into a string, and then you can have a very basic backup plan where it's trying to give us, like a data type, but it's not represented yet. But you can have a text type also, which can then just be shown right there. So you can have a version 1 of it, but there could be a versioning problem also to your question, right? Where there is a version 1 that the front end handles, but the server is now on version 2. How do we play around with it? You would still have to play catch up, but then the number of frequency of going to Play Store is now reduced to certain level. And any engineer on your team can just look at the JSON, look at the components individually, and say, oh, okay, this is how the mapping is. So that's the idea, but it's not something that you could do it on every screen, to be honest. But yeah, it'll definitely reduce your boilerplate code to some level. Yeah, sure.
So if I have a screen with a button and there's 2 different states.
Okay.
One state I need the button to be placed on the top, near the top, and the next state I need to be say if something changes, then if it's offline or something, it needs to be coming in the between.
Mm-hmm.
So how do we change the position with this?
So think of it this way, position. So when I talk about Compose as a declarative UI, right, you're going to be declaring a lot of things down the road. So the JSON is a super heavy thing now. If the JSON is just to represent one text of the button, and the click should do, say, some kind of a deep link, right? Let's say you have internal deep links. The intent of the button remains the same, but the position now changes. So positional data is now going to be passed down from the server. If you want a certain element to come in the center. So my question is, if it is the only element and you just want to place it in the center, it depends on what container I want. So if I take the epoxy example, there was a linear layout. Obviously, you can't place it in the center. You will have to do some kind of a stretching, push padding, and whatnot. But imagine if it is a constraint layout, which is the container which is being drawn at. Even for the Compose, there are constraint layouts now, right? In Compose, very stable and very powerful. If you want to center it, you can just pass one element. It should be center. Now, that element called center as one of the keys is going to be responsible on your end, on the front end, to decide how to draw that button. So the parent that's going to be hosting your child element is now responsible to know what the position of that element is. So if you can pass that data down, that will be better. But again, it's a pros and cons. You have to work it out with how big of a JSON is it getting if you're passing all the positional data as well. That's the trick in the server-driven UI. You can't pass everything down. Server can't be building UIs, it's a very data-oriented architecture, right? So you're not telling, oh, you should be aware of what this position is, and that would be a breaking change. Yeah.
One button, it's okay.
Sure.
If we have multiple items, then it's a problem. So do you recommend to have multiple screens?
No, see, think of it this way. If you have so your point is like if there's one in state number 1, you have 5 buttons, they're all 1, 2, 3, 4 in order. But in state 2, you have, just for the simplicity or brevity of this case, you reverse the order. It's 5, 4, 3, 2, 1. It's all about telling for each element that this is now in this position. So you can, instead of even doing any positional data, let's say it's all linear, just for the simplicity, the server is not going to send it in a different order. Whatever the order comes, I'm just going to draw it as that. I'm not taking control of it. I'm just saying I'm responsible to render, but I'm not taking control of how the rendering should be. Whatever position you want it, I will draw it in that position. Yeah. Oh yeah, sure, please.
Question. So please for you to bridge the JSON file. Is there a way to see somebody in JSON file and all that it? Client side without this.
Yeah, so I had this problem. So I worked with a small client, which they wanted they wanted that instant delivery of the UI. They had like 5 screens that were server driven. And the 6th screen onwards, it's the regular flow. Now, who's going to test this? The backend was not ready. This is the month 1 where we built the JSON. We had a handshake of contract between the front end and the backend. What we did is we built some, fake profiles. Like we had JSONs already ready in the test case. We would pass that data into the UI in an instrumentation test. Because it's just JSON, it's just data representation. We also built it as an offline first app. So we had some advantage there. So the local data store became the source of truth. And that's where we were able to test everything. We wrote some instrumentation tests, espresso tests. We wrote some automation on top. And to see whether if I pass a particular JSON, does the rendering occur the way we want it? So there were some control factors there from a testing perspective. But if there is, say, something that there's a version change on the state from the server side, before actually dumping it down, the production line, we actually would have another staging round, which would then test it on local. There could be manual, there could be instrumentation test, and we would then build actions on top. But like I said, this is more of a prototype because it's not like you would build this entire app on a server-driven UI. There could be one screen where you're actually doing testing, so the effort is kind of very narrowed down and focused to that screen. Or it could be like few screens out of say 100 within the app. So there is some flexibility there. But yeah, sorry if I'm not able to come to a very conclusive answer on that. Any other questions? I guess with that, thank you so much. Have a good day. I'm still here in the conference. If you want to talk to me, happy to be here. All right.